Hello, everyone. Welcome back. Today, we're going to be factoring these polynomials by grouping. So for this first one, what we're going to first do is we're going to take a look and group the first two terms together, and then we're going to group the second two terms together. We're going to take each group and we're going to fully factor just that group. So first thing I need to do here then is to decide what is the greatest common factor between y cubed and 2y squared. So the greatest common factor of those would be y squared. So that's what I'm going to do. I'm going to factor out y squared from here. And we're going to get y squared times y for y cubed and y squared times 2 for 2y cubed. 2y squared. Okay, then we have negative 9y and negative 18. So what is the greatest common factor between those? Well, that'd be negative 9. So negative 9 goes here. Then I'm going to put y here, since negative 9 times y is negative 9y. And then plus 2, because negative 9 times 2 is negative 18. And something you'll probably notice is that what we have in our brackets, both sets of brackets, is the same. And if we've done everything correctly to this point, that should be the case when we're factoring by grouping. So now I'm going to common factor out the y plus 2 from both. So we're going to end up with y plus 2 times y squared minus 9. And so now we've completed the factoring by grouping process. However, I noticed that y squared minus 9 can be further factored using the difference of squares method that we learned in Algebra 1. And so just in case you forgot it, the difference of squares formula says that a squared minus b squared is equal to a minus b times a plus b. So recall that this is also the case. And that's going to give us y plus 2 times y minus 3 times y plus 3, and that's going to be our final fully factored answer. Now, that last step really had nothing to do with factoring by grouping, but sometimes when we're doing factoring by grouping, if we end up with some part of it that can still be factored, generally we are still supposed to, fully factor it, and sometimes that involves using other methods as well. Okay, let's move on to this next one here. A cubed minus 5a squared plus 3a minus 15. So again, we need to group the first two terms together and the last two terms together. So what is the greatest common factor between a cubed and negative 5a squared? Well, that would be a squared. A squared times a is a cubed. A squared times negative 5 is negative 5a squared. Then what is the greatest common factor between 3a and negative 15? Well, that'd be 3. And now we can common factor out the a squared, the a minus 5. And this is what we end up with. Now, although we have the quadratic a squared plus 3, this quadratic is not actually something that we can factor any further. And so we can actually just leave it like this time, since we can't factor either part of this any further. All right, moving on to the last one here. First, we're going to group together those first two terms, m cubed and 4m squared. So what is the greatest common factor between those? That would be m squared. M squared times m is m cubed, and m squared times 4 is 4m squared. Then what's our greatest common factor between negative 9m and negative 36? Well, that'd be negative 9. And negative 9 times m is negative 9m, and negative 9 times times positive 4 rather, is negative 36. And now I will common factor out that m plus 4. And once again, don't forget that if we do have a difference of squares or really anything that's factorable still, then we should still take that next step and make sure we fully factor it as best we can. As always, feel free to leave any questions you might have about any of that in the comments section, and we hope to see you for the next one.